This recording is for Primary Math 3. I'm working in the Intensive Practice book, page 12. This is not word problems, but this is a mental math page, and it is really quite a step up from the workbook page that we've done that incorporated mental math. And so I'm going to, I just want to walk you through this and do some samples so you would see kind of how you could attack some of these problems in mental math. Mental math is a muscle. Treated like a muscle, at least in my opinion, and so sometimes things that we do, it takes a while to develop the muscle. So if your student does a couple of these and gets tired, then let them put it aside and come back and do, maybe 3 or 4 at a time. And if these skills help them, obviously, then let them see the recording or learn it yourself and then show them what you learned from the recording, whichever way you want to do. I'm going to go down the left column for the across the addition problems first, and then we'll go the other direction and do the subtraction problems next. So if I were doing this mental math, if I started in and tried to think, okay, well, I'm going to add the 5 and the 6 and that'll carry, and the 8 and the 7 will have something carry, and the 9 and the 8 will be carrying, that's a lot of carrying going on, and it's hard to keep up with that much in your head. So an alternative way to look at this is to realize that if I could just put 11 with this, which means I would take 11 out of this group, then I would have an even 600 to add with an even, not so even, 2,667. Subtracting 11 is easy. Notice, by the way, when you're trying to make an even 100, you want everything to go up to 9, except the last one is going to be a 10. So that's how I looked at that quickly and knew I wanted to have 11 on that. And then when I see that I have 6 hundreds and 26 hundreds, then I can realize that my answer for this is 3,200 or 3,267. Now, those of us who are moms might take a little longer to do that than our children, but your kids, my kids, did it much faster, learned it much faster than I was able to, and so don't shortchange them. They might be excellent at it, even if you struggle to see it. I would do this one in a similar way. I could add 7 to this part and get 7 away from that part. Remember, if you have a bucket, and you have 1,693 and 1,042, it's the same thing if you move your dividing line over 7 more, so that now in this side of the bucket you have 1,700. What do we have in this bucket? Well, if I lost 7 of those, okay, remember 42 minus 7, I could do the same skill. That's the same thing as 40 subtract 5, that's equal to 35. There would be 1,035 in this one. And it doesn't matter where you draw your dividing line, it's the same amount of toys in the bucket, or pieces of gum in the bucket, or candy bars in the bucket, whatever analogy your child likes best. And when I'm adding these two numbers, 1,700 and 1,035, 2,735 is a pretty clear solution. Part C, again, just doing the across column, which is the addition. I've got another skill I want to show you, but I keep finding that these are all the same idea, and that is if I get rid of one on the left side and put it onto the right side, and I have 3,813 plus 1,050, then we have an easy problem, right? 4,863. We don't have to write down this. This is what we're thinking. And many times you'll get to the point of writing down just the answer. If it helps them to write down an intermediate step, certainly that's fine. There's not room for it. Well, there's a little room on this page. You could rewrite a little bit on there if they have small penmanship to get that there. Okay, the next one would be a good one to show you another skill on. 3,085 plus 2,682. What if you looked at these as the hundreds, putting the hundreds together, and putting the ones together. Because I can look at either of those numbers and realize that it's 56 hundredths and 167, and all of a sudden I've mentally added that to be 5,767. Individually it's easy. When you're putting it together, you're just carrying the one number over, making the 100 into a 700 total. But by looking at it in terms of how many hundreds and how many tens or how many ones do we have, it does help the problem be a little simpler, maybe. Any of these strategies could be applied on any of the problems. It depends on what you and your child see when you look at it. They might see something they want to do. Again, I could demonstrate the same one. This one, maybe I'll just work this one both ways, because it could be really simply done either way. So altogether, I have 49 hundredths, and I have 41. So how many hundreds do I have? 49 hundredths and one more hundred is 50 hundredths with 41. Okay, as I went through all of that, I was trying real hard to show that other way to do it. I think I would really put these together and make hundreds out of it. 2,541 and 2,500 is, of course, 50 hundredths 41, 5,041. You can work either one, any of the problems, either way. Sometimes one will jump out as being much easier, and sometimes not. If you look at the down column, we're doing all subtraction for these, so mentally switch gears and get to a subtraction problem. 7,431, take away 2,909. If I were doing this problem, I would probably personally think of subtracting 3,000 and putting back in 91. No, I think I did that wrong. Hold on. Yeah, if I take away 3,000, then I took away 91 too many. So by taking away 3,000, I'm at 4,431, and if I'm going to add 91 back in, I'm at 4,522. Somehow it's easier to add than subtract, so if you subtract nice round numbers and you add the other one back in, you're in good shape. Again, on that one, if you saw this as this is your 121, and then of course I have 44 hundredths, which is what gives me the 4,500. I'm sorry, 22. That should have been a 2. There we go. All right, so then the next subtraction problem, letter F, 9,411, subtract 2,985. Again, I would probably mentally think in terms of take away 2,900 and put 5 back, or maybe I'd even just subtract 3,000 and put 105 back, because look how easy that is. That would give me 6411 plus 105, or 6516, 6,516. See how easy that is when you take away 1,000? And again, how many do I need to get to the nearest 1,000? I want the 8 to become a 9. I want the 9 to be a 9. I want the last digit to become a 10, because as you know from adding numbers like this, everything is going to carry and add another 10 and get up to 3,000. So mentally coming up with the number to get to how much do I need to go to add to get to the next 1,000 is easy, because I'm just counting by 9s on every digit and a 10 on the last digit. G down is 5,000 minus 1,627. A perfect way to say, to demonstrate this skill, if I'm trying to get up to 2,000, then I need 3, and 7 and 3, because I want this one to give me a 9, the next one to give me a 9, the next one to give me a 10, so all these 9s carry over and get to be 10,000, or an extra 1,000. So I might take this problem and say I have 3,000 and 2,000, and I'm going to subtract 1627, knowing that the difference between 2,000 and 1627 is 373. So when I add those together, it becomes 3,373. And again, adding is easier than subtracting. So if I'm looking at these numbers, I can come up with 373 pretty easily and realize that I have 3,000 left over once I do that. H, 10,000, take away 4,981. To make this number up to be 5,000, I just need 19. And so 10,000 is 5,000 and 5,000. And if I subtract 4,981, I know this distance to be 19. So 5,019 is my answer for that problem. The last one is letter J, 9,254 minus 1,420. We did this with addition. Let's look at how it works with subtraction. I could look at my hundreds and my ones separately, because 54 minus 20 is 34. 92 minus 14 is the same thing as 82 minus 4. That's 78. So 7,834 is going to be my final answer. Teaching your eyes to break the problem down and look at it in different ways is a great skill. All right, and that's the end of that page.